All right, in today's lesson, we are going to be talking about how to, in part one, only factor a quadratic. Part two, we will add the solving part onto the factoring. But today we are only going to talk about factoring a quadratic. So if you look up here, it says factoring is the process of separating a quadratic in standard form. Okay, so you don't have to write this part down. You can just kind of watch me off to the side here. Standard form we talked about in the first half of the unit looks like ax squared plus bx plus c. And we're going to take it into intercept form. And we talked about intercept form was where you had two sets of parentheses. And you could have a out in front if you had a GCF, but then we had x plus p and x plus q. So basically we're going from a statement that had no parentheses into a statement that would have two sets of parentheses. So in order to make this happen, the first thing you would do is it says it looks for a GCF, and then you go into the product and the sum, and the product and the sum is the one where we made, we just did the worksheet that had the x, and the product was the top number, and the sum was the bottom number. And then you had to find the two numbers off to the side. So that's what we call the product and the sum. And after that, then you have to use the box. So that's where you're going to draw a box like this. And for factoring, you're going to go from the inside to the outside. Okay. So basically what we're trying to get you to realize, and once again, you don't have to write this down before we even start, is we are going to go backwards from multiplying. So in the past, we gave you a problem that looked like this: 2x plus 3 times x minus 4. And then you made a box, and then you would put 2x, 3x minus 4 on the outside, and then you would multiply them together for the inside. And then you would have these 4 terms. And then you would combine your like terms, and you would end up with 3 terms. So basically for factoring, what we're going to do is we're going completely backwards. We're going to start with the 3 terms, and then we're going to end up making the x, which is going to help us get 4 terms, and then we're going to go to the box, and we're going to do the box backwards, which means we're going to start with putting information inside the box, get the stuff on the outside of the box, and then that helps us make our final answer, which is the 2 parentheses. So I just kind of wanted you to see that we are going to be going backwards from multiplying. All right, so with all of that out of the way, then let's get to the important part about how are we going to work all of these out. Well, today we are going to have 3 types of factoring. So the first 2 problems here, these are going to be type 1. So you can write this down off to the side. So type 1. And we know that this is going to be type 1 because eventually you're going to notice that your A number is going to be 1. And this is what I am going to call, instead of type 1, I am going to call this fast factoring. Because for fast factoring, you'll get to skip some of the steps. Okay, so here we go. First thing we do is we check for a GCF. There's not a number in front of x squared. That makes it a 1. So does anything go into 1, 3, or 10? And hopefully you say no. So no GCF. So then the next thing I do is I want to make our X like we did in our last worksheet. So here is the format for the X's always. When you make the X, you will always take your A times your C number for the top, and your B will be on the bottom. And then you have to find the two numbers for the side. And the two numbers you have to find for the side is what I call the factors. So they're the ones you must find. And the deal is the two numbers have to multiply for the top and add for the bottom. So I'm just going to call these factors, but these are the ones that you have to find. All right, so if I make our X, oops, sorry, the paper shrunk. Let's fix that. Okay. Okay, our A is 1. Our C is negative 10. So 1 times negative 10 is negative 10. And our B is negative 3. So you want to think what multiplies for negative 10 that adds for negative 3. And then hopefully everybody says, oh, I'm going to use 5 and 2. And I know that I have to have a negative 5. Because negative 5 plus 2 is negative 3. And negative 5 times 2 is negative 10. Now, for fast factoring, you get to skip the box. That's why we call it fast factoring, because you don't have to do all of the work. You get to skip making the box. So what you're going to do is you're going to go straight to the two parentheses. And you will always have x, because x times x makes x squared. And then what you're going to do is you're going to take your two side numbers. Whoops, I thought I changed the pink color. You're going to take your two side numbers here, and they are going to drop into the parentheses. One of them goes into each parentheses. So then your final answer would be x minus 5 and x plus 2. It doesn't matter which parentheses you write first, just as long as you have the negative with the 5 and the positive with the 2. Okay, the next problem. Okay, this one, always look for a GCF first. So 2, 4, and 30. Oh, I notice this one does have a GCF. So yes, GCF. I notice that all of them are divisible by 2. Now, if you have a GCF, you're going to take your GCF number and put it in front of your parentheses, and then divide each one by 2. So you would have x squared minus 2x minus 15, and that will go inside your parentheses. Okay, now we're going to make our x. Our A is 1. Our C is negative 15. So 1 times negative 15 is negative 15. And our B is negative 2. So what multiplies for negative 15? That adds for negative 2. And hopefully you would say, oh, I know, 5 and 3. And then if I want to get negative 2, that means I have to have a negative 5. And then I noticed that my A was 1 because I took out the GCF. So since my A was 1, that puts me into my fast factoring. So I get to skip the box. And I get to go straight to my two parentheses. So x. Now, because I had a GCF, make sure you take your GCF number and bring it down and put it in front of your two parentheses. So take your GCF number and bring it down. And then you take your two side numbers right here. So put -5 in one of them and +3 in the other. So you should have your GCF of 2 and then x minus 5 and x plus 3. So that is our first type, okay? And on your first type, okay, if you have a GCF, so it should be GCF, and then it should be x in your parentheses, and then x in your second parentheses, okay? And then inside the parentheses would be your two numbers that you have on the side of your x. Okay. Now, type 2, and hopefully you notice that type 2, there's going to be a lot more space in here because this is going to be the one that's going to require some more work. So type 2, and this one is going to be when a is not 1, which means even if you take out a GCF, your a is still not going to be 1. And unfortunately, this is what I'm going to call the long factoring. So that means it's going to have more work involved. So, i.e., you will not be able to skip the box on this one. You will have to do the box. Okay, so once again, please still start with checking for a GCF. So this one is no GCF because nothing goes into 4, 13, or 9. And you'll notice here that a is not 1, a is 4, so this is going to be the long factoring. But you still have to start with the x. So a times c, so 4 times 9 is 36. And your middle is -13. Now, what multiplies for a positive 36 that adds for a -13? Well, to multiply for a positive, you have two choices. You could either do 2 positive numbers or 2 negative numbers. But if I want to add for a negative, then I have to have 2 negative numbers. And hopefully you remember this from our previous lesson. So now hopefully you choose 4 and 9, because 4 times 9, -4 times -9 is positive 36, and -4 plus -9 is -13. Okay, so right now we're looking at this. We're going to go from 3 terms in the original problem into 4 terms, okay? So you're going to keep your A, but don't write your B. Instead of writing your B, I want you to write the 2 numbers that came up with your B. So I want you to write the 2 numbers that you put on the X over here, and then make sure you put your variable with each one. And then keep your C. So I went from 3 terms in my original problem to 4 terms. And the reason I wanted to go to 4 terms is because when you make the box has 4 slots, and you have to have 4 terms to put inside your box because it has 4 slots. So now we're going to put in these. Leave a little space here. Maybe I didn't leave enough space here, but leave a little bit of space because you're going to put numbers eventually on the outside of your box. So I'll leave a little space there. But now you're going to take these 4 terms right here and you're going to put them inside the box. So 4x squared minus 4x minus 9x plus 9. Okay, so there's a reason why we went from 3 terms to 4 terms, so that we can put those 4 inside the box. All right, so now what we want to do is we want to look up and down. I'm going to choose to look up and down, and I want to take out a GCF. So if I look at the numbers 4 and 9, does anything go into 4 and 9? And everybody's going to say, nope, just 1. So now look at the variables. I have an x squared and an x. And I would say, oh, they each have at least an x. So let's switch colors. I thought I switched colors. So then I would say, oh, well, they have an x in common. So their GCF is the letter x. Now what I would do is I would switch over to multiplication. So I would think x times what makes 4x squared. So x times what makes 4x squared. And hopefully you say 4x. And then for the top, 4x times what makes negative 4x. And that would be negative 1. And then here, I'm going to go with x. X times what makes negative 9x. And that would be negative 9. And then let's check to make sure we're right for the last spot. Is negative 9 times negative 1 positive 9? Yes, it is. Okay, so then once you have the information on the outside of the box, then we know that we can go make our final answer. Okay, so on the top of the box, I have x minus 1, so that's going to go inside of a parentheses. On the outside of the side of the box, we have 4x minus 9, and that goes into a parentheses. And that is your final answer. Okay, some little hints you should know. Okay, some little tidbits of information to pass along to you. Okay, you will always have x's around the first box, and the x's have to be positive. Okay, you could never have a negative around the x's. Okay, so always have an x around the first box here, and they always have to be positive. Negative signs will be with the plain numbers. So you could have a negative sign with the plain numbers, which are in the second slots. If you had a GCF in the original problem, then still make sure you put a GCF, carry that down with you, and put it in front of your two parentheses. Okay? But you will always have x's around the first slots, and the x's must always be positive. Plain numbers always go in the second slots, and the plain numbers may be negative. Okay, so let's go to the next one. Remember, check for a GCF. So does it have a GCF? And hopefully everybody says 9, 48, and 15 are all divisible by 3. So yes, this one has a GCF. So let's divide each one by 3. So 3, and then parentheses 3x squared plus 16x plus 5. Okay, what's my A? My A is 3, so that is not 1. So we are in the long factoring category. Okay, so long factoring because A is not 1. So we're going to make our X. We're going to do 3 times 5, which is 15. And the middle is 16. Now, 15 is positive, 16 is positive, which means both my numbers here are positive. So what multiplies for 15 that adds for 16? And that would be 1 and 15. Okay, so now we're going to go from 3 terms to 4 terms. So 3x squared. Let's change colors. Hold on, sorry. So 3, thought I'd change colors. Does not like me today. So 3x squared, and then don't write b. Instead of writing b, put the 2 numbers that came up with it. So plus 1x. Actually, just to be different, I'm going to go 15x. So plus 15x, then 1x, because it doesn't matter which one you write first. I don't care. Plus 5. Okay, so now I have to make my box because we're in the long factoring section. And then I'm going to take these 4 terms and put them inside the box. So 3x squared, 15x, 1x, 5x. Actually, I'm going to flip that around. I'm sorry, I just want to show you what would happen. I should have left it the same the first time. So I'll go 1x plus 15x plus 5. Just because I don't want you to think this will always happen. So let me change it back around. Okay. All right, and this is the reason why I wanted to do it this way on this one. Because now if I look up and down, you will notice 3 and 15. 3 and 15 both have a GCF. 3 and 15 are both divisible by 3, and they each have an x. So I didn't want you to think the top was always just an x. Sometimes it could be a number and an x. So now 3x times what makes 3x squared? Well, that would be x. X times 1 makes 1x. And 3x times 5 makes 15x. And 5 times 1 makes 5. Now, in this problem, we had a GCF, so don't forget about your GCF number. So bring your 3 down here for your GCF. Make your 2 parentheses. So 3x plus 1 and x plus 5. And you're done. So that is long factoring where your a is not 1, where you have to make the x and the box. Okay, the last type we're going to talk about today is type 3. And type 3, you're going to notice, is where you are missing the b term. And this is what we call the difference of squares, which I'm going to abbreviate all that. So difference of squares. And difference of squares has a lovely little formula. So a squared minus c squared equals a minus c parentheses a plus c parentheses. Okay, now you still want to check for a GCF. I mean, because that could happen still, but you can use the little formula off to the side. 81 and 4. Nothing goes into 81 and 4. Okay, and we notice that we're missing a b because it has an ax squared, but no bx. It has a plain number c. So it puts us into this category. Okay, and now what you want to do is you want to think what times itself is 81, because you notice here it has a and a, that's the same. So what times itself is 81? And you would say, oh, well, that would be 9 times 9. And then because you have an x squared, then you want to think of it really as like 9x times 9x. And then what times itself makes 4? Because you notice here it says c and c. So then you would say 2 times 2. And then you notice the signs are 1 minus and 1 plus. So then I would just have 9x minus 2 and 9x plus 2. So you notice the first 9x is the same, 2 and 2 is the same, it's just one is a plus and one is a minus. Done. Okay, so this one, once again, same thing, you would go, oh, I have the ax squared, I don't have a b, I have the plain number c. This one, if you forgot to check for a GCF, you would be thinking, oh, well, what times itself is 5? And you would come up with just a decimal, and you can't have a decimal. So then you would have to think, oh, there must be a GCF. And then I would say, oh, each one of these is divisible by 5. So then I would take out a 5. And now I can do that for the inside part. So I would think of that as 1x squared. So then that would be, oh, well, 1x times 1x. And then 25 would be 5 times 5. So then I would have 1x, which is just x, and minus 5 plus 5, and then keep your GCF of a 5 out in front. And then you're done. That's it. So really the only type that requires a lot of work is the second type, which is long factoring. The fast factoring and the difference of squares should go much quicker. And that's it for today.